So my name is Matt Carroll. Like I said, I'm a fourth-year PhD student in plant breeding. Have any of you guys in any of your internships or prior work done anything with any breeding companies or worked with any breeding? Have any of you worked as scouted fields? Yeah? So let's go around. Like, what did you do while you were scouting? What were you looking for? Diseases? Diseases as well? Pests? What rest of you guys? What else were you guys scouting for?
Plant diseases.
Okay. And so when you guys are out doing that, you're kind of doing a randomized sampling. It's an intelligent sampling, but you're not looking at the entire field, right? You're kind of taking blocks of the field and taking a look at, what diseases can we see or what different pests are there. And that's kind of the segue into this is why I think we should all use drones. Because with drones, we're able to, instead of kind of sampling a portion of our field, what we're looking at is, can we, excuse me, can we cover the entire field and then using some techniques called computer vision and machine learning extract this data? And what I mean by computer vision and machine learning is trying to teach the computer to start seeing as a human does, because what we see from a picture is not what a computer sees. What a computer sees is a bunch of numbers. And so working with some pretty awesome data scientists and computer vision machine learning experts at Iowa State, we're able to take some of the images that we're able to capture from our data and turn that into usable numbers, because just having images isn't really helpful. You still have to find a way to extract it. And so some of the traits that I'm talking about, so you guys all talking about disease stress. So one of the projects that we're working on is quantifying and identifying iron deficiency chlorosis in soybeans. Have any of you guys seen that or experienced that in any of your work? No? Okay. So when a plant's exhibiting iron stress, it means that there's not enough plant available iron in the soil. And when it's not available, the tissue starts to yellow. And for every level of so it's on a scale of 1 to 5. 1 meaning that it's very healthy, green, there's no iron stress in it. And a 5 meaning that the plant is severely stunted, very yellow and brown tissue, so not a very healthy plant. And for every one of those scales, they say there's about a 20% yield loss for any given line. And so from a breeding standpoint, we're not necessarily looking at what can we do as an actionable item for that disease. What we're saying is how can we, for the lines that we release, we want to make sure that when we release a line, we don't have a line that when a farmer goes and plants it in its field and we say that it's iron efficient, that it actually has some yellowing and has some yield loss associated with it. And so an example of that is, so one of the plots that I've had in the past, there's about 3,600 plots to go through. And so that would take about 5 human hours. So usually when we'd rate that, there would be one other rater and myself, and it'd take us each about 2.5 hours to go through the entire field. With these drones, we're able to fly that field in under 30 minutes. So there's a huge time savings from what one person can do. And the benefit of a drone is that it doesn't get tired, and it has pretty consistent ratings. Whereas I know myself, and I don't know about you guys if you notice this in your scouting experiences, but I'm a lot better in the morning when I'm fresh and it's not quite as hot out towards, when you start getting towards the end of the day at say 3 and it's hot and humid, there's a little bit more air in my ratings. And then there's also a good chance that, say Clayton and I get trained on the same data set, and I'm showing him this is what a 1 is, this is what a 3 is. Over time, there's a good chance that our ratings are going to drift a little bit. So there's some inconsistencies in the ratings that we're doing. And so you also have consistency not just between from person to person, but then within a person as well. And so not just talking about stress in plants that we can rate, but also looking at other things such as height, lodging, canopy area, growth parameters. So looking at how a plant is developing over the course of time. Typically in a breeding program, if you've got 1 or 2 people taking notes, you're going to see a plot maybe once or twice a season. With drones, you can fly them as frequently as you're able to and get a lot more information throughout the year. And then, like I said, so if there's any other traits that you guys could think of that you would think that you'd be able to utilize a drone for that that you guys have seen or you have an interest in? You guys think of anything?
Ask the question again.
So we've talked about plant disease and ratings with this. Is there any other traits that you guys could think of that would be useful or something that you'd want, from an agronomy standpoint, that you would think of utilizing a drone for, that you think you could utilize a drone for? Yeah. Ah, it's perfect. That's what I was looking for. So if you guys have seen like your granular or your field view, they put out a lot of satellite imagery with NDVI, and they use it as a management tool to look at maybe you need more nitrogen on a field here, or maybe there's some other plant health issues. The benefit of a drone is that the ground sampling distance you're looking at is a couple of centimeters per every pixel. What a satellite imagery is looking at is maybe 12 feet by 12 feet. So your ability to manage a smaller area and have a more prescriptive approach to things is much higher with this. And so get into that NDVI. So right now, both of these drones have RGB cameras on them, and so those RGB cameras are what we take with a regular phone. So it's what we can see in the visible light spectrum. Sarah will get into it a little bit in her presentation, but we're also trying to approach using hyperspectral, multispectral, and thermal imaging cameras. So what you get out of a thermal camera is obviously some heat stress, looking at studying things like that. Multispectral and hyperspectral cameras don't just look at what we can see, but they can also see into the electromagnetic spectrum that's outside of what we're able to see. So they call it the near-infrared region. And the near-infrared region has a lot more plant health information in it that we're able to extract. And so using those multispectral and hyperspectral cameras, we're actually able to get more accurate health readings on plants of things that maybe aren't showing stress yet, but do have a disease that we can maybe predict earlier than we would if we were doing normal scouting. I think that's, do you have anything else you think I should add, Danny?
What can you see from the height that you fly?
Yeah. Yeah, so flying this drone at say 200 feet, so the maximum you can fly is 400 feet, but I tend to fly most of the fields that I fly at 200 feet. And at 200 feet, the resolution is a half a centimeter per pixel. So looking at, say, one of the leaves or canopies over here, you'd probably be able to pick out if there's any leaf disease. You'd be able to see most of it unless it's really, really tiny. And as long as it's on the top of the leaf. If there's something on the bottom of the leaf, you're obviously not going to be able to detect it. And then depending on the sensor, it's going to change a little bit. And the throughput of your phenotyping is going to change as well. So if you're flying, at 400 feet, you're obviously going to be able to cover more ground quicker than if you're flying at, say, 200 or 100 feet. But if you fly lower, you're going to be able to detect more things on your leaves and have better object detection.
So when you were in undergraduate degree, what was your familiarity or how much of the drone usage did you have at that time?
I didn't know anything about drones before. I knew they looked cool and they looked like they were fun, but I didn't know anything. So I did my undergrad here. I worked for Dr. Singh, doing a little bit of research for him. But through some courses with Iowa State, there's a PhD program here called Predictive Plant Phenomics that works with getting plant scientists to collaborate with data scientists and engineers to kind of be able to use some of this cool technology. I've been able to learn quite a bit about not just the drone flights and learn how to fly a drone, but in addition to that, also learning how to process the data and actually get usable information from all the digital images that we're taking.
All the research you've done so far, what has been the most challenging from an agricultural viewpoint?
I think the most challenging thing has been probably integrating across platforms. So integrating for, say, yield prediction, looking at not just the images, but also looking at weather, soil parameters, as well as looking at the differences in elevation and whatnot. I think that's probably been the most difficult thing that we're working on right now.
So yield prediction, can you elaborate what we or you as a group here do?
Yeah, so as a group, we had a previous student, Kyle, who worked on yield prediction using one of the instruments, the ASD, using hyperspectral imaging in a diverse set of soybeans. So he was looking at soybeans that are maybe not what you typically see in a field. They would be the precursors to field varieties. And what he was able to do is take all of these bands, so he'd have about 2,500 bands, and using that information, taking the reflectance data, and then using machine learning and working with some of the data scientists, he was able to develop an algorithm that was able to predict yield very accurately in those varieties. And so we're trying to take that a step further. So actually moving towards breeding plots, and that's where fusing all that data. So we're actually working with Dr. Miller's group, if any of you know him, and they're creating very dense soil maps for us so that we can see the variation in the soil across our fields. And then on top of that, we're also adding in the UAV imagery. We also use a push cart to collect reflectance data to get plant health information, and then also add in the weather data. So trying to put all that information together into something that allows us to predict yield at a fairly high level and also make more accurate selections for the next generation of breeding lines.